One of the lessons I've really had to take to heart over the years is just because something's free doesn't mean it's worth taking. I had that problem really bad at the repair shop because I'd be offered all kinds of cool stuff all day, every day. But if I'd taken it, I just would have ended up with this big backlog of half broken things that needed my attention for years to come. That's not really what I want to do with my life. That being said, here's a Synsonics Terminator. These were a kid's guitar that they put out in the 80s. It had its own onboard amplifier, which is nice because then you didn't have to buy one. It was made by Gretsch really many years after their glory days and part of Mattel at that point. My special connection to it is just that one of the first actual guitar repairs I did for anybody was for a kid named Mitchell Farmer. I put a new saddle on a guitar very much like this one. I found this glorious beast in a dumpster in Grandview, Missouri. It was all covered in overspray from ceiling knockdown. They'd obviously left it in the closet while they were remodeling an apartment. Now, I should have just left it there for somebody else, but I grabbed it, and it actually worked once I replaced the batteries. Even though it's a little cheapy kid's guitar, it was kind of fun because it had a crunchy, distorted tone to it. And I thought about the guy from Blur, how he'd said, possibly facetiously, that the guitar tone he was looking for was a half-dead battery-powered amplifier, and that's what I really thought of when I played it. I probably would have eventually just gotten rid of it, except that I happened to have broken it. I think what happened is that I put the batteries in backwards, which there's nothing to keep you from doing it, and it's not well marked. So I figured that just to get rid of the thing, I better fix it, because I'd feel bad if I just threw it away. I decided that I might as well try replacing all the caps and resistors, and I did, and it still didn't work. The problem, I think, was the main chip, which is the one thing I couldn't really replace. I had to look around to see if there's anything I could use, and without knowing more about it, I thought I'd better just replace the whole thing. You can buy off of Amazon an LM386 amplifier board, and they're really cheap. They're a couple dollars a piece, and I got 6 of them. It's a good thing I did, too, because 2 of them turned out to be bad, and I didn't find that out until after I'd installed them. So to test it, I just hooked up the speaker in one pickup and fiddled around with it to make sure that the amplifier board was going to work. Now there's a bunch of different versions of this board, and the one I happen to have, the pot wasn't really very well placed for what I was doing. The simplest thing to do was just cut off the legs of a transistor and use it to extend the pot farther out, and then I'd put a little lug inside to mount the board to through a screw hole. I also had been watching this video from that Not a Luthier guy, and he'd made a distortion circuit. And I don't remember if I actually made that one or a different distortion circuit, but I thought as long as I had a 9-volt battery power in the amplifier, I might as well have a distortion circuit built in with its own control. So I made up the whole circuit, and once I actually turned it on, it did not work. And what I found out was that I can install it on a regular guitar and it works just fine, but it doesn't seem to work on this. So I axed that whole idea, and I decided that I would just install the amplifier board as it was. To do that, I had to plug the holes, and I have a plug cutter, and I just drilled some holes in the center and cut it out with the plug cutter and glued those in place with super glue. And I used a Forstner bit to thin the guitar top out enough to get the pots through, because the pot that comes with the LM386 amplifier board is actually meant for a panel mount and not quite the thickness of a guitar top, and that was the easiest way to handle it. Just to have a piece that matched, I made an LED holder out of one of the extra pots off the old board, and I just cut the shaft off and left enough length for the 2 nuts and counterbored it, stuck the LED in there with some super glue. I need the LED so I don't end up leaving the thing on. Once I got it together, it worked, but I was pretty frustrated with how quiet it was. And so I looked around at some different forums that were talking about these boards, and they had said you could add a capacitor to it and get the gain up. So that's what I did, and it actually worked very well. I also decided that I wanted an 1/8 inch output jack so that I could plug regular headphones into it. I ended up using a push nut and drilling a hole in the bottom of it, and it made it so that I had just enough bite with the back of the jack that I could hold it in the body. Don't try to drill washers while holding them in your hand. Because that always happens. And so the super glue's not there to hold it for real. It's just enough to get those couple of turns to get it to seat. In the instrument, this all looks pretty complicated. So let's have a look at it outside the instrument. At the start, you have a 3-way switch. And on the outer 2 lugs, it has an input from each of the pickups. I have a pair of output wires. The orange and white one goes to the audio amplifier board, and the solid orange one goes to the output jack. Now, I don't have a volume and tone control, and that's because I don't really think I'll ever be plugging this into an amplifier. It's not really the point of this instrument. If you're reusing the original output jack, the wiring is like this. That's the hot and that's the ground. If you wanted to have a volume and tone control, you would replace this output jack with this circuit right here. It has the input from the pickup, goes to this lug on the volume pot. It then bridges over to this lug on the tone control, the center lug. There's a 0.022 microfarad capacitor that's soldered to the back of the case and to this lug. All your grounds are just tied together, and then your output wire goes from the center lug of the volume pot to right there on the output jack. This particular LM386 amplifier board has an input where you would plug an 1/8 inch audio jack into it, and that's not useful for me, but I didn't really want to go to the trouble to take it off the board. So I figured out where the tip was, which happens to be this leg right here, and these 2 legs right here were the ground. It actually amplifies really cleanly, but that's not the sound I wanted from this instrument. So what I found out is if you bridge a capacitor, it says 106. If you bridge a capacitor from the last 2 pins of the chip, then it'll increase the gain and make it a really nice distorted crunchy sound that's actually really close to what I was after. If you look at the chip, you see there's a little notch there. The opposite end is where you want to tie your capacitor into it. So these 2 lugs here, opposite of the notch. You can see the inputs and outputs are nicely marked on this one too, with nice little screw terminals. I have just a regular 9-volt battery box. On the original it had a pair of 9 volts, but they weren't in series, they were in parallel, so they were still only outputting 9 volts. I've put a switch right here, and I've tied an LED in so that I have a light
so I don't accidentally leave this thing on and kill the batteries. It has a light on the board, but there's no real way to see it when the instrument's assembled. The audio output goes to this 1/8" headphone jack. I've replaced the original jack with this because I don't have a lot of 1/4" jack headphones around. Seems a lot more useful this way. If you were using the original output jack, here it is again, this one would go to your speakers. This would still be the input from the audio board, and this would still be the ground from the audio board, and then this one would just go right to your speakers. This actually isn't a very good output jack, but what I like about it is you can really see how it works. Here's the input coming from the audio amplifier board. Here's the output that goes to the speaker. The grounds are all just tied together. When you plug in your headphone jack, it pushes on this leg here and it disconnects the speaker output. See the little contact in the back? That's how it turns off the speaker when you plug the headphones in. Simple. This is a 2-inch 8-ohm speaker, 3 watts. And I bought it just for this instrument, but the truth is the 4-ohm speaker that's in it sounds just fine and better than this one. So if I were doing this and I had a good speaker in the instrument already, I think I'd just stick with the original one, see what happens. When I was originally thinking about doing this video, I was going to do it as a joke, and I'd take the Synsonics Terminator Guitar apart one piece at a time and replace every single piece. First the tuners, then the neck, then the body, then the electronics, and then when I was done, I'd have an entirely different instrument, and I'd have the reassembled Synsonics guitar set next to it. And I would have thought that was funny, but now that I fixed the Terminator, though, I don't really feel a need to make a whole nother instrument, so I don't know what I'm going to do with this stuff. It's really just for demonstration purposes. It's kind of neat. Maybe I'll stick it in something someday.
I thought about adding a tone control, but the truth is it doesn't need one. With the selector switch and the volume changing the dynamics of it so much, I don't think it would really be an advantage. I think it'd just be more confusing. Anyway, I guess it's all fixed, but now what do I do with it?
Here, kid. Good job.